So welcome to today's session. So today we are going to be talking about computing for the dot product between two vectors. Okay, so when we refer to the dot product, what are we actually referring to? So there's this question on the board which says that let A be equal to the components of 1 and 2, B be equal to the components of 2 and negative 1. A, using the component form, find A dot B. B, hence, using the geometric form of the dot product, find the angle between the vectors. And C, state the relationship between the vectors, acute, right, or obtuse, and justify your answer. Okay, so let's briefly explain what dot product is. So when we refer to a dot product, so supposing you have two vectors, A and B. So dot product measures the amount of one vector in another vector. So we are looking at the amount of vector B inside vector A, or the amount of vector A inside vector B. So a practical example is supposing you have a plane B, and then you have the ground, which is A. Then you have sun rays coming from this section. Now when the sun rays hit this particular point, you are going to have a shadow being casted on the ground, right? So when you have a shadow being casted on the ground, then there's going to be a distance that shadow is going to take. So now the amount of the shadow being casted is caused by the sun rays hitting the length of B that we see here. So that becomes a portion of B merging into A. So when we refer to dot product, we are literally referring to the amount of that B that we see on A. Okay, so this particular length of shadow is very, very, very important to us. Okay, and when it comes to dot product, there are two forms. The first form is the component form. So if you have A dot B, supposing A has components of A1, A2, and B has components of B1, B2. Now the dot product between these two is going to be A1. I'm going to have the x-axis multiplying the x-axis, and then the y-axis multiplying the y-axis, and then you are going to sum the two. So you are going to have A1 by B1 plus A2 by B2. So this is how you compute the dot product in the component form. Now in the geometric form, which is typically what we are seeing here, you are going to have A dot B is equal to the magnitude of A times the magnitude of B cos theta, where this refers to theta. Theta is the angle between the two vectors or the two planes. So now let's get into the question. So A says using the component form, find A dot B, which is going to be simple. So we have A, which is 1, 2, and B, which is 2, negative 1. So to find A dot B in component form, we are going to have this multiplying this and that multiplying that, then we add it. So it's going to be 1 times 2 plus 2 times negative 1. So we are going to have 2 plus negative 2, which is going to give us 0. So the relationship between A and B is 0, right? It's 0. Okay, now let's move on to the next question. The next question says, using the geometric form of the dot product, find the angle between vectors. Okay, so now in the geometric form, we know that A dot B is equal to magnitude of A, magnitude of B cos theta. Now we just computed A dot B, which gave us 0. So we have magnitude of A, magnitude of B cos theta. So now we have to find for the magnitude of A and the magnitude of B. Okay, so we know that when you are finding for a magnitude of any vector, we are looking at the square root of the squares of the components. So we have A1 squared plus A2 squared. Okay, which is going to give us square root of 1 squared plus 2 squared. And that is going to give us square root of 1 plus 4, which is going to give us square root of 5. Then we move on to magnitude of B, which is also going to be square root of B1 squared plus B2 squared. And that will give us square root of 2 squared plus -1 squared. And that is going to be square root of 4 plus 1, which is going to also give us square root of 5. Okay, so substituting it into this form, we have 0 is equal to square root of 5 dot square root of 5 cos theta. So now we can shift this to the left hand side so that we can find for cos theta. So when we shift it to the left hand side, we are going to get 0 over square root of 5 dot square root of 5, which is equal to cos theta. And that is going to give us 0 is equal to cos theta. So now we can send cos theta to the left hand side. So we are going to have cos inverse of 0 is equal to theta. And this is going to give us 90 degrees. So theta is 90 degrees, right? Okay. The final question says, state the relationship between the vectors acute, right angle, or obtuse angle, and justify your answer. So now let's look at how acute, right angle, and obtuse angle looks in relation to these two vectors. So supposing you have an acute angle, then you are going to have vector A and vector B in this way, where theta is less than 90 degrees. Then a right angle is going to be vector A, vector B, where theta is 90 degrees. And then an obtuse angle, you are going to have vector A, vector B, where theta is above 90 degrees. Okay, so now with the theta that we had theta to be equal to 90 degrees. So once theta is equal to 90 degrees, then this is the picture that we are looking at. So that states that it is a right angle triangle, right? Why? Because the angle between them is 90 degrees. And we already computed that A dot B equals 0. When you have A dot B equals 0, it literally also means that if you have A dot B, which is equal to the magnitude of A, magnitude of B cos theta, since theta is 0, you are going to have A, magnitude of A, and magnitude of B since theta is 90, so we have cos 90, and cos 90 gives us 0, right? So everything is going to collapse down to 0. Okay. Okay, so this is how you calculate for the dot product between two vectors. So the next session, we are going to talk about the cross product. So kindly subscribe to this channel if you are new and comment on this video. So I see you on the next video. Bye bye.